Hello friends, welcome to Power Electronics. Today we will discuss the Thyristor Protection. For the reliable operation of the Thyristor, that it should not increase the specified rating. If the specified rating is increased, the Thyristor will get damaged. So in practical, the Thyristors suffer from two things, that is over voltages and overcurrents. As Thyristor is a very delicate device, it will get damaged or falsely triggered on. So if the thyristor is turned on, that means di by dt is very large. Also by the dv by dt, it is triggered on falsely. So it produce a charging current IC. I will discuss this in later part. So we have to provide some kind of protection that so that SCR won't get triggered falsely without our permission, as other devices are also under risk. So when thyristor is forward biased, by the when we gave the gate pulse, then the anode current start flowing. The charges get spread across the whole area. If you can see in the diagram that we have given a gate pulse, so the anode current start flowing. We know the middle junction in the forward conduction mode, the junction J2 is reverse biased. This junction, middle junction, is reverse biased. So some kind of charges are trapped here which do not allow the further conduction. When we have given the pulse, these charges spread here, as they are designed to do so. They spread out and make the conduction possible, so the anode current flows through it. But if the rate of rise of anode current is very high and do not give enough time the charges to spread down, so what will happen? It will form the local hotspot. Is it same like, for example, if we have taken a wire and it has strands, and strands are designed so that they can take equal current, and so there is no load on the wire. But if one or two strands do not work or they are broken, the large current passes through a single strand, which may cause damage the wiring. So same like that, if charges are not spread properly and a node current flows through it, it will cause local hotspots. Thyristor design permits the spread of conduction to whole junction area as rapidly as possible. If the rate of rise of anode current is very large, the spread velocity of charge carriers form local hotspot. What is the problem with the local hotspot? It will cause heating, and heating will destroy the SCR. So we have to provide a protection against di by dt. DIT value can be maintained by an reduced by an inductor, di by dt inductor, whose value is 200 to 500 ampere per microsecond. Typically, di by dt limits value of SCR are 20 to 500 ampere per microsecond. This method of determining inductance of di by dt inductor is as you can see in the diagram. Local hotspots can cause heating, and that heating can damage the device. So also it can be triggered out by dv by dt. As we know, in the forward conduction mode, junction J1 and J3 are forward biased and junction J2 is reverse biased. So what happened here? There is some kind of voltage across the middle junction that behaves like an capacitor, and this capacitor produces an charging current. As you can see in the equation, IC equal to dq by dt. As we know, q is equal to CV. So C is the junction capacitance and V is the anode voltage. When we differentiate it, we get this value, that is IC charging current equal to junction capacitance dV anode voltage upon dt. This charging current also can suddenly or falsely trigger down the SCR without our permission. So we have designed an snubber circuit. This is a circuit where RS is connected, resistance is connected in series with the capacitor across the SCR. When we applied a voltage Vs across it, the capacitor Cs gets short circuit. So the voltage across the SCR is equal to 0. But this Cs is not enough to prevent the accidental turn on the device. So what we have connected a resistance Rs in series with the capacitance. As before the turning on of an switch, the capacitor was previously charged with the value Vs. So this capacitor was already charged as Vs. So what happened here? It was already charged. When we turned on the switch, what happened? This capacitor began to discharge through SCR. So it starts discharging. In order to limit the magnitude of the discharge current, what we have connected an resistor Rs in series with Cs. Now SCR is turned on. Initially discharge was, for example, the current here I was Vs by R, but here the resistance value is very low, so the current is very high, which can trigger down the SCR. But if the value of R is high, then the current will be lower, so it will not falsely trigger down the SCR. Designing a snubber circuit is very complex process, so its numerical value we will solve in the next classes. Thank you very much.